Hi everyone, I'm Chen Yuanyuan from MSc program in Artificial Intelligence and Machine Learning at the University of Limerick. And today I'll be presenting my dissertation project titled Smart ED, an emergency prediction and resource recommendation system for aging and diverse populations. So why this topic is important? In 2024, over 87,000 emergency departments visits were recorded at the University Hospital Limerick, and more than 50% of patients aged 75 and above required admission. Ireland's elderly population is also growing rapidly now, and this is placing increased strain on hospital resources. However, current systems lack early warning tools to help hospitals anticipate and respond to these surges. And this can lead to overcrowding, long waiting times, and staff overload. So you can see this graph shows the population trend over time for different older age groups in Ireland. As you can see, it increased sharply in recent years. And this demographic shift is a clear signal that demand for emergency care will continue to rise, and proactive planning is essential. The aim of this project is to build a predictive system that uses real ED data to train machine learning models, and deploy batch predictions on AWS, visualize trends and results through a dashboard, allow users to simulate different scenarios in a web app, and supports real-time interactions through Docker-based APIs. And here is the overall architecture of the system. We start with historical ED data, including patient age, gender, time, and more. This data is cleaned and used to train a predictive model using scikit-learn with random forest and XGBoost. Once trained, the model is deployed in two ways. The first one is batch predictions. We schedule via cronjob, generate daily 7-day forecasts, and store results in S3 for visualization. And another one is real-time API inference, which responds to user input instantly via a Dockerized model. And both outputs feed into a unified Streamlit web app, which presents insights in two tabs. One is a dashboard, and another one is an interactive panel. The data module involves importing historical data, historical ED visit data, adding simulated variables like weather and holidays, cleaning fields such as age, time, and ambulance use, all implemented using Python, Pandas, and scikit-learn, and optionally packaged into Docker for easy deployment. And we mainly predict hourly ED visit count, but if time allows, the system can be extended with submodules to predict such as the admission rate among old adults, ICU transfer rate. And these enhancements help hospital plan staffing beds and critical resources more accurately. The Streamlit dashboard has two key components. One is a trend comparison of historical versus predicted ED volumes, and another is an interactive input panel where users can enter values like time, weather, or elderly visit counts to get real-time predictions. And based on the results, the system can provide suggestions such as increasing on-duty staff or advising redirection of non-critical patients. So these are the variables user can input into the simulation. And based on those input, our system will do some real-time predictions. So overall, the full system is combined with one model and a web app. It can be wrapped in a Docker image. This allows easy deployment on any local machine or cloud platform like AWS EC2 and with consistent environments and one-click setup. And looking ahead, what we can do more in the future, the system could connect to live hospital data and external APIs such as real-time weather feeds. With this, the batch prediction could become fully automated and run hourly, updating the dashboard in near real time. And besides this, for the model sides, we can also extend to have more models like ambulance usage forecasting, admission and ICU rate prediction, average waiting time estimation. Like these additionals would help hospitals make faster, smarter, and more adaptive decisions. And this is the roadmap of my project. And so the first step, I'll just sort the data and build the model. Then I build on AWS. After that, I build the app and API, and then do some function like suggestion feedback. And after all those done, I'll write and finalizing my dissertation. Thank you for watching this presentation.